Section 10.3, question E41, and we're supposing that the null hypothesis is false. Which test will have more power? So we really only care about power if the null hypothesis is false. If it's true, no matter how much power we have, we're not going to pick up on a significant result, or we shouldn't. It's possible we could make an error, but we're really concerned with power when the null hypothesis is false. Of course, we never truly know, but we want to have the power so that when it is false, we can pick up on that result. So a test with 0.01 and a test with 0.05, which one is going to have more power? Well, we're more likely to pick up on a significant result when our standards are a bit lower. And when I say lower, it sounds funny because the 0.05 is actually a higher number than 0.01. But remember, what we're looking at is the p-value lower than our alpha? So it's a lot harder to get lower than 0.01 than it is to get lower than 0.05. So a test with alpha 0.05 does have more power because we're more likely to reject that null hypothesis with this standard being a little more relaxed than this one would be. So a test with a sample size of 46, a sample size of 23. The higher the sample size, the more power we're going to have. Why? Well, think about how the test statistic is calculated. We're going to divide by the standard error, which is standard deviation divided by square root of n. The higher an n we get, we're going to divide by the square root of n, so we're going to have a lower and lower standard deviation, standard error, and the lower our standard error is, the higher our t-test statistic will be, so the more likely we are to reject the null. So the higher the sample size, the more power we have to pick up on a significant result if the null hypothesis is actually false. So if the medicine works, higher sample size, more likely you are to see that it works. Okay, a one-sided test or a two-sided test. A one-sided test is going to have more power because it's similar to this right here. We're concentrating all of our allowance for error on one side of the distribution. Instead of spreading it out into the two tails because we're not sure which way it'll go, we're pretty sure which way it'll go, or maybe it doesn't matter if it goes the other way, like when we were looking at industry standards and airplane window strength. So a one-sided test is going to focus all that potential error on one side of the distribution. It's going to make it easier for our t-test value to get in that critical region and reject the null hypothesis. So a one-sided test has more power, assuming it's in the correct direction.